Welcome to the fourth session of the 5-day National FDP on RTASsE 2022. As a convener of the FDP, we are welcoming Mr. Sudip Datta and Mr. Dishwan Dasgupta on the FDP. Welcome, sir.
Thank you.
Thank you.
Myself, Satpal Chakraborty, Assistant Professor, Department of CSE and moderator of this session. Now, I may take the privilege to introduce Mr. Dishwan Dasgupta and Mr. Sudip Datta as a keynote speaker of this session. Mr. Diktiman Dasgupta is an IBM Executive IT Architect, Open Group Distinguished Architect, and IBM Senior Inventor with 24 years of industry experience in enterprise architecture, SOA, and enterprise integration, blockchain, cloud, and ISV program leadership for complex projects and initiatives. In his current role, Diktiman Dasgupta is the Chief Architect for Green IT and Cloud Sustainability Program in IBM Consulting. Previously, Mr. Dasgupta led ISV program and blockchain technology practice in Customer Innovation Center, India. Mr. Sudip is a senior IT architect in IBM with multiple years of experience in blockchain technologies, hybrid cloud, and implementing complex blockchain solutions in customers. In recent times, Sudip is leading sustainability from tooling and technology standpoint. The topic for today is sustainability and green IT in the context of hybrid cloud. Now I am requesting Mr. Dipyaman Dasgupta and Mr. Sudip Datta to enlighten us with their valuable knowledge. Sir,
Hello. Thanks, Satadal, for the introduction. Let me share my screen. One second. Present now option. Give me a second. United Somali. And 1 second.
Yes, it is
yes, yes,
visible.
yes,
Okay.
yes.
Okay. So I'm going by screen. So this is a very interesting topic. We started sometime years, 1 year back in IBM, and sustainability is topically subject to it is a big subject, right? If you think about sustainability, it originally came from all these 17 sustainable development goal from the United Nations, and there are each goal is defined on the food, water, climate. Now, when we think about sustainability from the business purpose or giving services to client, IBM is also thinking it from the big different bucket standpoint. One is say sustainable supply chain and circularity. Another is sustainable finance. So one such major topic is green IT, where myself and Shudip are working. And our purpose is in green IT, in typical IT stack that we have, typical compute stack, whether we are having our application on private data center, on-prem DCs, or on public cloud, how I can reduce the carbon waste from my stack. So that is the key area of topic today. And if you think about industry priorities, it is a very hot topic today because many of the countries are going for the net zero agenda. Many of the European countries, especially, are having 2030 net zero agenda. For India, I think Modi, Prime Minister Modi has declared it is 2070. So almost every country having a net zero agenda. Now that will not happen in a single day. It is a prolonged process. And as this is a new technology division, a new technology area, very less maturity also. That means many of the times we have done sustainability being not conscious. That means in architecture domain, in performance management is existing for a long time as a discipline. So during performance management of our IT application or IT infrastructure, the measures that we take, the approach that we take that impacts finally compute, storage, or network, that itself is a sustainability lever. So many of the cases you will find if you go by this discipline that existing solutions, existing technologies have been rebadged with the sustainability in mind, or it is being called out eventually. But beyond that, sustainability itself is a new discipline. Technology is immature, a lot of new solutions to be developed, and it should be explicitly measured and tracked. So today, the in industry, even in industry, the critical point or the problem that we are facing, even we come back or come up with the sustainability principles or levers or technologies or techniques or approaches or best practices, we have very minimal footprints of tools to measure the actual carbon footprint and the benefit that we are having. Also today, the non-existing part is the benchmark. That means if I go to a travel and transportation industry or if I go to a mining industry, for certain set of action, what should be my desired carbon emission and energy consumption, nobody has created that level of methodical baseline. So that's how, as we don't have baseline today, we don't know whether we are below the threshold or we are doing good or bad. So a lot of problems. But net the good thing for industry as well as academia is that this is a unstructured discipline, and 42% of CIOs is an important area to grow, and that's why industry will have a lot of focus. Means each of the CXOs, like especially CIOs and CTOs, they are the key consumer sustainability. A new role being created in industry that is called Chief Responsibility Officer. You will find every organization, every website you search with Coca-Cola plus sustainability, you will find there is a sustainability page. You will find HSBC, all banks have the sustainability page. That means today every industry have a sustainability agenda. So that agenda either going by giving that a service to their customer through their products and services, at the same time reducing their operational cost. So few key takeaways like why we should do the green IT, why we should think about sustainability. If you see today, 1% of global power consumption, think about 1% of entire global power consumption is done by current data centers. And if you think about next 7 or 8 years, it will be 7 to 8%, maybe even more, because of more usage of internet, more energy savvy algorithms, usage of AI driven, analytics driven solutions. So these are power hungry, right? And as soon as that will be the power hungry things, they will consume more power and create more carbon. And there is also balance between that. I mean, same data center, when getting the power from green energy, non-conventional energy, they're emitting much lesser carbon, but this power generation centers getting the power energy from the fossil fuel like coal and others, that will be emitting energy a lot. So that's how this is a huge area to focus on, concentrate and bring a discipline not only in industry but also in academia to think through that what technology, what process, method, tool, software engineering practice I should bring in so that I do better job in case of carbon emission. Second is the second pillar is also very important for academia. That is, we are producing tomorrow's software developers, right? Once upon a time, we used to write code just to fulfill our functional need, right? So we have a functional spec given to us and used to write, translate it into design and used to write code to fulfill that need. Eventually, the other dimension like non-functional requirement came in. Like I should write code being security in mind. I should design architecture with backup and recovery, disaster recovery in mind. I should design a solution with resilient, more fail-proof. See, a lot of non-functional requirement came into existence. So you can think of this green is a new non-functional requirement. So when you write a code, maybe we should think of some best practices that will help us to write the green code at a later point of time. This deck, Shudip will talk about more about this thing. But this is also a very important discipline for our engineering students and the tomorrow's coders. And third is hybrid cloud. Hybrid cloud bringing being a platform provider. They are doing huge work in sustainability. You think about Google. Google will go full green hopefully by 2025. Maybe Amazon will go by 2030. That means as a cloud provider, when they are bringing their data center, their cooling mechanism, their HVAC, all their technology, better chips, so they will make the platform as green as possible. But as a solution provider like IBM, Accenture, or the companies who are building the solution, they should build efficient code, efficient architecture on top of that efficient platform so that overall contribution to environment becomes much greener. So today, who are major source of emission, as I already explained, that is data centers. Data centers are huge consumption or the creator of energy thing, the carbon emission. Second is the big data and analytics. So lot of programming, complex algorithm, and data intensive problems, which is dependent on a lot of data parsing analysis. So all these are very compute intensive. So as soon as you are burning the processors, it is becoming compute intensive. It is more get power hungry. It is generating more power. Third is security algorithm. Think about blockchain. Think about the encryption methodologies in the ledger and other complicated algorithms, encryption keys for security to making our system more and more secure. It is also burning a lot of carbon. And fourth is the internet usage. So it is during the COVID time, most of we are confined at home. We dependent on fully internet, and internet usage increased a lot. That's why it is more network transmission, data transmission, and that's why the carbon emission. And also think about the 5G in the revolution in the telco industries. All will impact in carbon. So net sustainability and carbon consciousness should come everywhere. And like the way it is, I am talking about technology today, but it has also a huge financial part. Like a lot of banks are coming up with a new business model. They are coming up with digitization so that it becomes less paper intensive, less but more digital intensive. Secondly, new business avenues are coming up like green finance. You start with the term green finance, you will find tomorrow's lot of startups will get better benefit, better loan through these green financing schemes. So climate friendliness will be an important business angle too. And third is social. So it has a that's why the ESG term came in. So it is a social dimension also, that how we should make our people our ethics and data ethics, so all kind of things. And not only that, personal consciousness in terms of making our environment safe, proof, planting more trees, carbon offsetting. That means being in company, I'm burning a lot of fuel, but at the same time in Congo I'm planting thousands and lakhs of trees. So that's a concept of social part. That means social benefit that I'm bringing to the environment, ultimately impacting the carbon emission. Now, as part of green IT, there are, which is our topic today, is three major areas to focus. One is, as I told already, data center. When you think about a data center, few things come in mind. One is data center as a facility. It has a huge building, it has light, air conditioning, cooling mechanism. So all these things are you should take into care when you think about green. So what solution you can deploy so that you manage the data center assets, you automatically switch off the light, so you bring optimization at the facility level. Second important part, how bring optimization in the infrastructure level. So you have a lot of servers, racks, and those servers are power hungry. Means many a time that servers are not working, but still grabbing the power because it is connected to the power, and that's why how we can shut down those servers automatically, or we bring better utilization to the infrastructure so that we need less amount of infrastructure. So a lot of infrastructure that are there today in data centers which are underutilized, means they have maximum peak load say 20%, but still they are existing, and once upon a time in the year probably peak load will be 40%. That's why you still retain those servers with that capacity. That is a wastage of money and environment. So that's how we can get rid of this kind of situation, how we can move to cloud, so make it better utilized solution with a better platform. That should be our motto. And third part is the green application. So whatever application, many of the applications we have designed earlier, monolithic application, mainframe based application, legacy application. So when you are remodernizing or modernizing those application, or you are building a new application, how you should bring design principles for sustainability, which make it better optimized in terms of compute. So these are typical services that we offer to our customer. Like we do customers sustainability maturity assessment, we do the strategy and roadmap, we understand customers' problem, we define a blueprint for their sustainability. We also bring some of the tools, deploy them on the private data center to measure the carbon and assess the carbon hotspot. That means if I take a slice of a data center on certain platform like AIX or x86, I measure the carbon footprint, that how much CO2 in kg that virtual machines, say 50 VMs or 35 servers are emitting, and resulting the carbon emission or kilowatt of energy consumption. So those are kind of services that we help to client for strategy part. During transformation part, we help in the green coding, we help in defining an architecture which is better sustainable, we help in data modernization or platform optimization. So I'm bringing cloud platforms, I'm bringing Red Hat, so how I can make it better. And the third pillar that we give the services to client is the IT operations. So it is also a very interesting domain. That means if you have large accounts or clients, they have their hundreds of applications running. Those applications are also emitting carbon every day. So how I can bring best of the tools, technologies, that I define some KPI, that okay, these are my five green KPI, that I will measure carbon emission, I will measure utilization, I will measure carbon footprint. So I tell client that these are my five KPIs, which indicates my performance of the running application, and I deploy a certain advanced tooling to measure and monitor those emissions. So that's how our service portfolio look like. Now I think this is a chart on the method. That means we know that what service we are trying to project to client, but this is how we are going to do. So previous chart was more like what, and this is more like how. That means in the carbon journey, we start with carbon estimation. That until unless I know how much I am emitting, how I can improve that. So first step in the journey is I should know that how much I am emitting from my infrastructure or application. Secondly, with that raw measurement data, I should be able to assess, that is maybe manual, that may be AI driven, that I should assess and tell client that okay, these are the five hotspot or burning spot where you should improve. Third part is optimization. So here you should bring all tools, technologies, optimization technique. So all the things, green coding approach. So whatever methods, tools, technology you have today in your bag, you apply that to make green coding and green solutions, and especially in terms of carbon emission, in terms of energy consumption. So you do all the good thing that make your solution green. Green coding is one of them. And finally, operate. So these are some IBM specific tools that we are doing. KR is more like internal turbonomic and already existing tool, widely adopted for optimization. So this is how I will stop here. Now I'll pass on to Shudeep. But before that, if there are any questions on the overall thinking process or overall green IT, I'll be able to help. If not, I'll pass on to Shudeep. Shudeep, can you hear?
Yes, Didi. Am I audible to everybody?
Yeah, I can at least hear you. So I think it
Yes,
should be same for
yes, you are
others.
audible.
Yes, thanks. Didi, can you please move to the next slides? Okay. Now, as Deeptiman was saying, uh, Deeptiman, can you please come back to the previous green coding slide? Yes. Thanks, Deeptiman. As Deeptiman was saying that we have this sustainability journey with respect to the IT infrastructure and how we can achieve a energy conscious program. Okay? So there are several ways to do it. Now, for example, when we see in the industry, the current trend is, as Diptiman was saying, that we first measure that how much carbon your IT is taking. For example, you have a website. So how much that website is emitting in the carbon when some user uses that website. Okay. Now, I'd like to share my screen quickly here.
So let me stop then sharing. Yeah.
Yes. So there are certain interesting fact over here. Okay. Can you see my screen? So it should be a blue information. I am just scrolling it up. Okay.
Ah, yeah.
So can everybody see the screen? Okay. Now, what I did, it was interesting. You can also do this. So there is a site called websitecarbon.com. You can see what is the URL here. Now, what you can do is you can go and give any URL, and this will measure that how much carbon it is being emitting. Now, what I did, I went to Siliguri Institute of Technology's main site. From there, I went to the College of Professional Studies, and I picked up one random page. Okay. Now, this is the URL of that page. Okay. Now, what I have found here, this site actually measures from your technology that you are using behind the scene, plus it sees that in which location of the world this particular site is hosted. Okay, and where it is hosted. So this, from this information, it try to find out that how much energy is being when I access this page, this particular page, this SIT, sorry, if I go to this particular site, so how much? So this is the page actually. Okay, I was trying to measure over here. So if I say skip now, and from there I went to you have multiple colleges, right? So that part I have gone to that particular page. Okay, and I found out this page is going to take how much every time I hit this server, then this is the approximate number of CO2 being emitted by this entire process. Now, this page is written in HTML. From the HTML size and how much distance it has covered over the network. So based on some calculation, it gives me some. Okay. Details will be announced. Okay. May I have your attention? So every time, yeah, give me a second. My office is running a drill right now. It will be stopped. They're assessing the situation. Please do not panic and carry on with your work. Details will be announced shortly. That's your boss. Yeah, sorry for the inconvenience. So let's come back here. So it is the 2.1 gram of CO2 every time this page is hit. And it just says that every day, if I mean, over a year, if the 10,000 hits are there, I mean, every month there is some 10,000 hit on this page. So which is equivalent to 293 kilo of CO2, same weight as almost two sumo wrestlers. Okay. Or the boiling it I mean if you use a fossil fuel and you can have this much cups of tea. So this is some fun information here. So what is important here, that how much energy it is converting. So for example, 652 kilowatt of hour. Now Didi was saying that I mean some organizations are doing a carbon offsetting. We call it as carbon offsetting. So you measure that this is the carbon you are going to emit. Now, in order to compensate it, what you have several ways to compensate it. One of the ways that you plant trees. So these are some standard 14 trees. If you plant, then in a year, I mean, uh, this amount of carbon dioxide will be absorbed by this many number of trees. Okay. Now this is one of your site. Now I have gone to this program site, RATSSC site, which is hosted in Google. So that site is consuming less amount of energy. So this is the home page of this particular program. So which is again, see, only 80% of this. Now why it is only 80% of this? The main reason is that this is hosted on Google Cloud. Okay. Now if you see, the Google Cloud has a lower footprint, and it is sufficient to plant only 4 trees instead of 14 trees over there. Okay. And this web page appears to be running on sustainable energy. So you are already sustainable. So since it is running on cloud, so Google has made sure from which data center this site is being hosted. It is running on sustainable energy. That means it's some form of green energy. Either it's a wind power, or it's a it's solar power. So where we do not burn the fossil fuel. Okay. So these are some interesting fact about your website. So I'll go back to the main part. Okay. Now as you can see, we have already, if you consider your you are our client, and you have one web page which is hosted on your private data center or some website. Didi, may I request you to share your screen once again? So and from there we move to cloud. So you have one site in cloud, one site in Google Cloud, and one site is in your private data center. So you can see there is a difference between these two sites and the power consumption. Now, why this is happening, we call it as a powerful platform lift and shift. So if you go to cloud, the cloud servers are much more efficient than you with respect to energy. So that is one way of reducing or achieving the sustainability, or reducing your power footprint. Didi, may I request you to share back? Okay, I think.
One second.
Yeah. Thanks, Didi. Okay. Now let's come to the next part. Now the technology remains same. You have used in PHP or some language to generate this web page, and the same language you might have used here also. And you see there is a difference when you move from the hosting platform. The next part is that but we are, this is not only sufficient, and it is not possible for everybody to move to cloud for several reasons, and those reasons are sometimes the monetary reason, sometimes there are some regulatory reason for which you cannot move to cloud. Okay. So we handle a lot of clients, and every client has their obligation to host them in the private data center. Does that mean in that case they cannot do anything? Like in the sustainability, can't they run their workload, their program, or reduce the carbon footprint of the program? So there comes this green coding part. Okay. Now by green coding, by definition, what we mean, that green coding is a coding practice that aims to solve the problem, your programming problem or your business problem, while taking into account the goal of the reducing the energy consumption. So I know as a student or as a part of our curriculum, we are being taught to write good programs. For example, some programs which is running with lower complexity. Okay, so we are given a mathematical task or an algorithm, and we asked to find out that which algorithm is better. I mean, based on a big O notation. So whether it is a more efficient algorithm or that is another for example, there is a question that which sorting algorithm is good, whether it's bubble sort is better or the shell sort or it's binary sort or the tree sort, which one is better? And there are several aspects of it. Sometimes you consume more memory with respect to less runtime, and for example, merge sort, which might be the best one, but it consumes a lot of memory. And memory also, if you use more and more memory, it will consume more power. Now, which one is better? Now, similarly, when we apply the green coding principles or green coding practice, we take into account that how much energy I am going to emit in the climate. If my program runs, how much energy it is going to emit. Now, uh, how to apply the green coding in your day-to-day life or in your programming? So there are some seven aspects of it. Now we need to learn all, I mean, at least some couple of them, okay, or take into consideration. Again, I am telling you that this is a evolving field. So today it is some seven aspects we have found. Maybe in tomorrow it will become 20 aspects, okay, that you need to take into consideration. So for example, the very first one is the choice of programming languages. Okay, Didi, may I request you to go to the next slide? Now, when we talk about the energy, now where this energy is being consumed when you write a program, energy is consumed, you need to take into four dimensions here. One is your time, how much time it is going to take your program. Okay, that is one I mean attribute of your program. The program that runs faster is